Okay, so let's look at how IBM Model 1 now defines these two probabilities. Remember, we have two parts to the model: conditional probability of an alignment given an English sentence and the length of the French sentence M, and then secondly P of F given EAM. So I'm going to go over these two sides of the model in turn. So firstly, for the alignment model, IBM Model 1 is the simplest model you could think of, which is just assuming that every possible alignment is equally likely. So remember, we have some English sentence, we have the null word, I'll call that E0, and then E1, E2, E3 up to EL, and then I have some French sentence length, so I have M positions on the French side. So we're just going to assume that for each of these positions, each of these L+1 alignments, so this word, for example, could align to any of these different things, each of these has probability 1 over L+1, because there are L+1 possibilities, the null word plus each of the English positions. And I have M French words to choose, so the overall probability is just going to be 1 over L+1 to the M. So again, this is just assuming that every possible alignment is equally likely. It's the dumbest possible model. It's a major simplifying assumption, but it gets things started. It will get us off the ground. So now let's talk about the second part of the model. This is the model of P of F given AEM. So what's going on here? We have some English sentence E. So for example, we might again have the dog barks, and I'll write null as the 0th word in the sentence. We have some length of the French sentence, say M equals 3. So we have 1, 2, 3 positions here. And we have some alignment. So for the sake of argument, let's assume we have this alignment here. First word in French is aligned to the first in English. Second word in French, second word in English. Third word in French, third word in English. Okay. So how do we calculate the distribution over possible French sentences? And let me give a particular example. Let's assume that we have, so this is F1, this is F2, and then finally we have F3. So how do we calculate the conditional probability of this particular French sentence, where we're conditioning on the entire English sentence, the alignment, and the length of the French sentence? So in this particular case, it's going to be the product of three terms. We'll have T of le given there, and intuitively this is a parameter corresponding to the conditional probability of seeing the French word le given that we're aligned to the English word there. It's the probability of this English word there emitting the French word le as its translation. The second term is T of the second word given dog, and then we have a final translation of this third word given barks. So one T parameter for each of the French words, where we condition the identity of the French word on the English word that we're aligned to. The abstract form of this is as follows. So we have a product from j equals 1 to m. Remember, m is the length of the French sentence, so we're going position by position in the French sentence. And at each point we have T of f sub j, that's the jth word, conditioned on E of a sub j. So this is the identity of the English word, which the jth French word is aligned to. So we're essentially assuming that each of these French words is filled in turn, independently from all of the other French words, actually conditioned only on the identity of the English word that we're aligned to. So here's another example of how this goes. This is coming back to the example I showed you earlier. Assume again we have this English sentence, this French sentence. We have the English length 6, the French word, French length 7. And let's say we have this alignment. So I'll draw this here. That's what this alignment looks like. Then in this particular case, sorry, this should also be conditioning on M, which is 7 in this case. So in this particular case, the probability of seeing this particular French sentence conditioned on E and the alignment is a product of T terms. And notice I have one T term for each French word. So we have one T term for each of these 7 French words. And at each point we condition on the English word we're aligned to. So le is aligned to the, for example. Program is aligned to program, and so on and so on. So intuitively, IBM Model 1 corresponds to the following generative process. So we have some English string. So for example, we might have the dog barks. And we have some length of the English string. For example, m equals 3. So we have 3 possible French words. And so here's how we proceed. So firstly, we pick some alignment, A, uniformly at random from the space of all possible alignments. So we might, for example, pick some alignment like this. Okay. Having done that, we then fill in the French words with a product of probabilities. So we might, for example, choose these 3 words. And this part of the expression would have probability T of le given dog times T of chien given there times T of a boy given there. Of course, this is a very unlikely alignment given these 2 sentences, but it's nevertheless possible. And so intuitively in the second step, the generative process is for each French position, we choose a French word at random from the distribution defined by T. So for example, this word is chosen from the distribution T of the word given dog. And this word is chosen from the distribution T of the word given there. And so on. So first step, choose an alignment uniformly at random. Second step, fill in the French words one by one, conditioning only on the English word to which we're aligned to. The final result is a model of the following forms. We have conditional probability of F and A given EM. We have product of 2 terms. Firstly, P of A given EM. Secondly, F given AEM. That's what, just an application of the chain rule to this. And given this particular form for IBM Model 1, the final expression is the following. So this corresponds to the uniform probability of alignments. This corresponds to picking each French word based just on the English word which we're aligned to. So later in this class we'll see how to estimate these T parameters. Okay, so we're going to have some parallel corpus as the input to our model, and from this we're going to get TFE for all English words E and French words F. So we're actually going to get a conditional probability. What I've shown you here is one such entry from a model which is actually trained on real data, and this is for an English word position, a list of the most probable words in French once we've trained the parameters of this model. And you can see it's actually done a reasonable job. If you know some French, this seems like a reasonable set of translation probabilities. So position can be translated as this word, it can be translated as position. In French, there are other possibilities like this word, and so on and so on. Okay, so this is a typical kind of lexicon you might get from the output of this process. For each English word, you get a probability for every possible French word.